Symbol Superstore is expanding its digital footprint across three core areas: e-commerce, supply chain, and transportation management. To get these systems online, we have to execute precise configuration choices across virtual infrastructure, serverless functions, and managed databases. We achieve this using both the Google Cloud Console and the CLI. The CLI, or Command Line Interface, is a text-based tool used to execute direct commands against cloud resources. Getting these specific configurations right is what separates a fragile pilot project from a resilient, production-ready environment. In the Google Cloud Console, you define the exact hardware. We select the E2 medium machine type, allocating 2 virtual CPUs and 4 GB of memory. We also anchor this virtual machine to a physical location, selecting the US Central 1 region and US Central 1-A zone. Virtual machines require manual management. For the supply chain pilot, we shift to a managed container environment using GKE. GKE, or Google Kubernetes Engine, is a managed orchestration system for deploying and scaling containerized applications. This diagram shows our required architecture, a private standard regional cluster, isolated entirely from the public internet. Because this is an early development pilot, the cluster only needs to be accessible to internal team members. We opt for a standard cluster rather than an autopilot configuration, giving developers the control to modify the architecture directly. We also bypass multi-node high-availability replication to keep immediate development costs down. Choosing the right foundational compute requires matching the deployment architecture directly to the current lifecycle phase of the project. For workloads that don't require persistent infrastructure, we use serverless technologies. This slide outlines Cloud Run's capabilities. It provides serverless container management based on a service resource, exposing a regional endpoint that replicates across zones and scales automatically based on the volume of incoming requests. To deploy these serverless components, we move away from the console and rely on explicit command line syntax. Look at this CLI command for our transportation management function. We deploy it using a Python 3.9 runtime. Crucially, the -trigger-topic truck data flag connects this function directly to a pub/sub telemetry stream. Pub/sub is an asynchronous messaging service routing event data between independent applications. While our trucks stream data through pub/sub, other workflows react to static files. To trigger a function the moment a new file is fully uploaded to a cloud storage bucket, we point our resource to a different target, the google.storage.object.finalize event. A serverless architecture only functions properly when you configure exact event triggers to accurately connect your decoupled services. Deploying the database backend through the UI requires navigating an 8-step manual process. You create the instance, select the engine, name it, assign root passwords, pick the version, and manually configure the primary and secondary zones. We condense that setup by executing a single command. Here is the syntax to create the supply chain database. We execute gcloud SQL instances create, followed by the database name, and define the hardware parameters, 8 CPUs and 512 megabytes of memory in US Central. However, this baseline command contains a critical vulnerability. As written, it deploys a single instance in one zone, meaning it lacks automatic failover if that specific zone goes offline. To guarantee database high availability, we must append one final configuration. As highlighted in this diagnostic review, you add the -availability type argument to ensure the database can automatically fail over to a secondary zone. Cloud providers manage the underlying physical hardware, but the system architect remains fully responsible for explicitly configuring data resilience. Across these 3 architectural pillars, the CLI deployment syntax follows strict patterns. We use compute instances create for our virtual machines, functions deploy for serverless event handling, and SQL instances create for managed databases. Mastering these exact UI parameters and CLI flags is the definitive skill required to implement and deploy robust cloud solutions.